Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by TechStrong and Gremlin. My name is Cody J. Brown, and I'm the host of TechStrong Learning. We have an exciting presentation ahead of us, but before we begin, I have just a few housekeeping notes. First, today's session is being recorded, so if you miss any of it or you'd like to share it with a friend, you'll receive access to the on-demand recording after the webinar concludes. If you have any questions, I want you to send those in using the Q&A tab on the right side of your screen. And if you have any comments or you just like to tell us where you're tuning in from, go ahead and use that chat tab and we can talk there. Finally, at the conclusion of today's webinar, we'll have a giveaway for 4 $25 Amazon gift cards. So stick around to see if you're one of our 4 lucky winners. On to our topic today. We are talking about the synchronization of chaos, and I'm joined today by Jason Yee, Director of Advocacy for Gremlin. At this time, it is my pleasure to turn the floor over to Jason. Jason, thanks for being with us.
Thanks, Cody. Yeah, so let's talk a little bit about chaos. Chaos theory has been something that I think is completely fascinating, and I know it's like kind of a nerdy subject, so I think a lot of other folks might be interested in it as well. So hopefully, I think you can all see my screen here, but I wanted to start off with a few really bad jokes that one of my high school teachers used to tell us when we were in class. So I can see some folks are in chat already. So for the first joke or the first riddle, I'll throw that up on screen and you can reply back in the chat. But the question is, what do you do if the wheels fall off of your igloo? So we'll see if folks want to respond to that in chat, or we'll just go to it. The correct answer is blue, because ice cream has no bones, obviously. You probably all got that. It makes complete sense. So the second one sounds maybe like something that Google would use as a interview question where they expect you to start analyzing things. How many pancakes fit in a doghouse? Now, if you're in that Google interview, your response might be, well, what's the mass of a pancake and the volume of a doghouse? And yeah, the answer of this, well, Francis, it's commented in chat, nothing, I guess. And that's actually the correct answer. Good job, Francis. None. And the reason is because my motorcycles don't have doors. So before we dive into the rest of the session and I explain these really incredibly stupid jokes, a little bit about me. Thanks again, Cody, for introducing me, but I am Jason. I'm the Director of Advocacy at a company called Gremlin. I've gotten the opportunity to work at a bunch of amazing places previously as an engineer, doing various things. In my spare time, I play a ton of Pokemon Go, and I make craft chocolate from beans that I buy, and I roast them and make chocolate. But the important info on this slide is if at any point you have questions, particularly as you're thinking about things after this session, or maybe you're watching the video later, feel free to reach out to me. I am jyee@gremlin.com. And I do have a YouTube channel as well, which I haven't been posting to, but I've got some older stuff there that I think is interesting and might be beneficial for you. So back to those really stupid jokes. Oftentimes when we think about what is chaos, right? We think about chaos a bit like those nonsense jokes, that chaos is completely random, that there's no connection between cause and effect. And I think that like me, most of you tend to lean towards rationalism, right? You're engineers and you're coders and you're technical people who think like scientists. And so as a scientific brain, as somebody that believes in rationality and logic, everything operates within constraints, and that includes chaotic systems, which got me interested into chaos theory, right? Like this idea that complex systems don't just produce random, unexpected results. The reason that your code is breaking isn't blue because ice cream has no bones. It's because of something unforeseen, but still within the boundaries of the system that you've designed or that you're working in, right? And so one of the reasons that I like chaos theory and that I think it's incredibly interesting is because we all work with complex systems. That's the whole point behind modern development, right? Between having services and breaking things down and working with other teams and other engineers to build things is it's all complex. There's all these moving parts. But within that, there are patterns and interconnectedness and feedback loops, repetition, uh, similarities, all of these things that chaos theory is all about, right? That chaos theory states that within the apparent randomness of our systems are these underlying pieces that actually aren't so random, that aren't so maybe chaotic, but or unpredictable. Uh, and so I think that what makes it attractive is that all of these concepts are very similar to what we do, right? We may not understand exactly how something works in a given moment, but if we can understand the constraints that we're operating in or that our services or our software is operating in, and we can observe how it operates, how it functions, we can start to pick up on some of these patterns and traits, and we can use that to learn more about how things work. And so in a lot of ways, this is how we approach troubleshooting incidents, especially if you're on the SRE or ops or DevOps side of systems or engineering. You get paged for a service that you didn't write, that you probably don't know much about, other than it's running on the servers or the infrastructure that you're responsible for. But on some sense, you know what those metrics should look like, right? When the service is working properly, you know the general environment where it's running. And even though you aren't familiar with the exact code, you can start to get a sense of the boundaries and maybe how it should be operating, and you leverage that. One of the underlying characteristics that I wanted to point out in this statement about chaos theory is the interconnectedness, because I think that's extremely important. So I've actually got a video here. I'm going to flip over to the video in our platform, which hopefully you can see. And we'll only watch maybe a minute or so of this, if I can actually. All right. So one of the interesting areas of chaos theory that I've recently dove into is called the synchronization of chaos. And so from that video is a great demonstration of this, right? When the video starts out, the metronomes are obviously not synchronized. And it doesn't dive into it in the video. They're not actually even tuned to really be on that exact same frequency. And so when they start this, they have roughly the same tempo, but they're not in sync and they haven't been set to match. And they're only connected by sitting on that same platform. And so the interesting thing about the synchronization of chaos is that it happens all across our universe, right? Not just physically connected things like those metronomes. Synchronization of systems happens in chemical reactions. It's been found to happen with the electricity and magnetism and light and gravity, right? The reason that there's a dark side of the moon is it happens with gravity. Over time, the Earth and the moon became in sync. And so there are examples of this synchronicity in nearly every way that systems can interact. And so with systems that seem disconnected or only loosely connected, I think this has value or has some relationship to the systems that we work on. And so I want you to think about your systems, the systems that you're responsible for, whether that's a service or infrastructure or particular bit of code. And I want you to think about what are the other systems that that's connected to, right? Maybe post that in chat, right? What system are you on and what other systems is it connected to? So while you post that in chat, one of the larger topics of reliability, as we think of that, is how do these connections influence the reliability of the systems that I'm responsible for, right? So I'm hoping maybe in chat that if folks, again, want to comment there, but think about this, right? What are some of the ways that your systems are influenced and interconnected with particular respect to reliability? So as you think about your systems, here are some of the ways that I've thought about interconnections. And this isn't exhaustive by any means, but the most obvious to me was service dependency, right? As we break down applications into component services, particularly as organizations go from standard, monoliths to maybe some service-oriented architecture, and they keep breaking those down to microservices, it becomes inevitable that one service relies on not just a single other service, but many services. And then we start to have this cascading effect, right? Of those services then in turn rely on more services. And so sometimes these services are internal. For example, if your service provides some sort of user functionality, it might rely on a user authentication service to ensure that the user is actually permitted to perform the action or use the function that you're building, right? Sometimes they're external. For example, if you're using a service like Okta or Auth0 to do that user authentication, or maybe you're hosting assets in AWS S3 bucket, or you're querying data from an Azure SQL server, right? There are all these services that we use, and when these services go down, or they misbehave, or they have problems, they can cause your service to go down or have issues. Good example of this on a recent project that I was working on. My service depended on a third-party service. I was building just a fun sample app and using an open API. And so one day, my data processor that I'd built had started generating weird error message. Not all the time. Generally it worked, but sometimes it was like roughly about 25% of the time it started failing. And so, as any good engineer, I started doing some debugging, looking through my code, figuring out what's going on. What is this weird edge case that I'm looking at? And as I did that, I started to think, well, it's probably an issue with the external service, or at least I think it is, because my code seemed pretty okay. I'm not the best coder, but it seemed passable. So I did a bit of testing to ensure that I'm getting the right data back. And I found something along the lines of this, right? I did the debugging, like I've got this API endpoint, I curl against it. I don't know if anybody else has seen this. I surprisingly should have realized, because this wasn't the first time. But obviously, don't return a 200 OK if it's actually like a 504 error. And secondly, that's not valid JSON. You can't just stuff strings and wrap it in curly braces and call it good. So yeah, that was one of these ideas, right? Of I'm dependent, I'm interconnected to systems when I'm building this, and obviously they affect the reliability of my application. The next way that I thought about interconnectedness when I was thinking about things was what we use to build our services, right? We're all familiar with this in terms of security. For example, uh, maybe you were affected by the log4j vulnerability. Thankfully at Gremlin, we weren't. That's not what we use for logging, but actually, even in my day-to-day work, there's a sample application that I normally use, and I tried to pull from, install it on Kubernetes, and it referenced the repo where those container images were, and it broke because those container images were no longer available. The folks in the open source community around it had decided that they couldn't rightly put those images out there with that bug. But I feel like these issues, like if you experience that log4j issue, it's nothing new. Right? You probably remember even just a few years back to the guy that deleted leftpad, right? And it recently happened with some other node modules, right? Like when leftpad happened, like 80% of Node.js apps would no longer build. And obviously it's an extreme example. And as someone who kind of hates Node.js, like I feel like it happens all the time in Node, but honestly, like we all use open source projects. Like it's cool that there's modules out there, whatever language you're using, and it's cool. Like you should be reusing publicly available code when you can. It saves you a bunch of time. But at the same time, it definitely increases your risk for crazy things happening. So I could rant on about Node and why I hate it, but like obviously a lot of our interconnectedness is because open source is so powerful. It's easily accessible. Again, you should use it as much as you can. You shouldn't be writing your own database or your own queuing system or your own CMS because these things exist and they're free and they're open. But along with that, obviously, there's the understanding that you're sharing not only the same software, but the same reliability or unreliability as a lot of the community out there, right? So the third way, interconnectedness, the third way that I thought of was actually kind of interesting because I think we're naturally predisposed to thinking of these technical ways that we're connected. But I thought about culture. And what do I mean by culture? Well, no matter what your services or apps are, or how they're built or what components they use, they're all connected and influenced by the culture in your organization. Is your company culture sort of the deploy first and test later philosophy, right? Just get the code out the door. We don't care if there's bugs, we'll fix it later. Or maybe your company is a culture one of releasing MVPs and rapidly iterating, right? So people get like a really basic functionality and it may be pretty bad, but you're just wanting a little bit of feedback so you can go and improve that and constantly do that. Or maybe you work for a larger organization that needs to coordinate between all the teams and actually cut releases on a more scheduled basis, right? Because there's a lot of communications and awareness and documentation and things like that that need to happen. Engineering culture influences everything that we do. So an example of this, I kind of worked at one of those places where the culture had some flaws. It was a small digital agency and we hosted a lot of websites for our clients. So we would do the work of building them, a website or web app, and we'd make a little bit of money by hosting it. We were definitely not doing DevOps. And by that, I mean, like we had Jenkins for automated build and deploys, but we weren't doing DevOps in the sense that developers, which is where I was, we didn't really work well with ops. We did a lot of what I call shenanigans rather than working with the ops team. And by ops team, I mean like there was just two guys that were responsible for the servers that were literally in our closet in the office. This was way back, so AWS wasn't really a big thing. Anyway, someone had managed to convince our ops team, which again was like 2 guys, that we needed to have limited sudo permissions to do things, because as we were hosting, sometimes you need to update the Apache configs to do things for a website, right? To resolve things, maybe have some redirects. And so it seemed like a pretty reasonable request, and not having a good rapport with the ops guys, they were like, fine, we'll do this, but we don't really trust you. So they set it up so that you could run sudo just for Vim on specific files, right? So basically set up the permissioning like, cool, if you need to make changes to the Apache config, here's the way you do it. And this is the one way that we allow you to do it. The fun thing though, if you are a Vim or a VI user, is that if you sudo VI, guess who you're now running as? You're running as root. And Vim is amazingly powerful. And so Vim has this fun command prompt thing. So if you go inside Vim, and you can do it on any system that you have sudo access for Vim or VI, open up Vim, and then rather than colon like WQ to save and quit, you do colon SH, and that dumps you out into a shell. But again, the fun thing when you're sudo and you're in VI is now you're root. And when it dumps you back out onto the shell, congrats, you're now root. So we abused this all the time to get into systems and do things that we weren't really supposed to. Never malicious. I'm happy to say that I didn't actually accidentally take down any servers while hacking root. I'm not so happy to say that this doesn't mean that no servers ever were, because they definitely were, just not by me. But this is a good example of how culture connects our systems, right? Even if we work on different services, if someone in the org in your company has adopted that culture of let's hack root rather than let's collaborate and work more efficiently, then your apps begin to synchronize on that, right? We all become susceptible to it because of this culture. So these are the 3 main categories of interconnections that I came up with within the chaotic systems and complex systems that we are all a part of. I'm sure if we spent some more time, we could probably find some additional areas, but it also led me to think about synchronization in a different way, right? So in chaos theory, the synchronization of chaos, the impressive part, the reason all of those metronomes in that video, why that video is so cool, is that it seems to run counter to entropy. So if you remember back from your physics, your high school physics, generally in systems, they naturally tend from order to disorder. But in the synchronization here in this system, the system of those metronomes became more ordered, which is strange, and it seems counterintuitive. And so as I thought about this, it made me think that, yes, we have cascading failures and there's brittleness in our systems. And we have sometimes risky cultures of hacking root. And these are natural entropy. Things breaking leads to more things breaking, cascading outages, things like that, right? That seems natural. You know, it's not all that surprising given the work that we do. But it made me wonder, the synchronization of chaos, if we could synchronize to reliability. Could that pull unreliable outliers into line to create more order, more reliability? Could it make a natural trend towards that more reliability? So it made me think, how can we use our interconnectedness to improve our systems? Right? And so taking those 3 ways that I saw that things connect, it made me think, well, if we have interconnections, how can we improve reliability with interconnections, right? When it comes to service dependencies, I think one of the best ways to achieve synchronization of reliability is sort of a bit of a contradiction. You can simultaneously make a service less dependent on others and introduce a stronger influence for reliability by using intermediaries such as API gateways and queues. Like this is the standard way that we're taught to actually loosely couple our services. So as an example, in my previous experience, right, that service that I was talking to, that API that returned that horribly malformed JSON, not really JSON response, said it was a 200 okay, but it was actually a 504. If I had an API gateway, I could ensure that my service didn't receive a 200 status code for that 504 message, right? With most API gateways, I can configure it to only return 200 if the payload matches what my service or my API contract defines as a valid response. But I can also have this alerting, I can have alerting and logging set for that, right? I can immediately be notified if the offending service is sending bad responses and are not compliant with our agreed upon standards. Similarly, with a queuing system, I can enforce that messages into the queue conform to a format. Aside from providing the benefits of decoupling and asynchronous handling by using these systems, if my service makes a call to another service and that service tries to submit a message back to me that doesn't follow the right format, that service now gets the error and not me. So all I have to do is provide proper coverage for the cases that I don't receive a response. So it's a weird bit of a conundrum, but it's sort of our standard practice of using an intermediary, provide some decoupling, but at the same time, while there's technical decoupling, there starts to be a little bit more of an enforcement, not quite to the level of what I called cultural, but it starts to set up standards. So decoupled in one way, but much more coupled on standards in another. When it comes to coupling with shared components, I think diversification in service-oriented or microservice applications is important, right? Again, this is sort of a conundrum, but if we think about the left pad issue or the log4j issue, right? Would you rather have had to update every service in your application or just a couple? So part of the benefits of using services is that you don't have to standardize on a single language or framework or use the same components. The idea behind decoupling is using what works best for the requirements that you have. But also, as you do this, you can adopt the best reliability features from one system and apply it to others. So you can start to synchronize on the good ideas and the good approaches that you find rather than the specific components and frameworks themselves. A good example of this is back when I worked at Datadog. The backend systems were a mix. We used Python, Go, there was some Ruby, there was a bunch of Java. The monitoring agent that we had, that customers would install on their systems, so the agent that would collect those metrics, ship them back to the metrics backend in Datadog. Well, that monitoring agent that customers installed used to be written completely in Python. And one of the things that we saw from using Go in our backend was how fast it was. And also that it used far less resources. So we could write something, compile the Go binary and ship it out. And we were suddenly using far less memory, far less CPU, and the responses were so much faster. So obviously these are great things and they're fantastic for an agent. If you're asking someone to install software to do monitoring on their systems, having that be a smaller binary that's faster is amazing. But the agent also used integrations, and Python was much easier for customers to read and write, not to mention that they didn't have to compile it. So we ended up mixing the two. The core agent was rewritten in Go, and we had a little bit of software that allowed the integrations to still be in Python. So we had this nice diversification. But again, we could synchronize on the good parts, right? Use the parts that we wanted, use them to our advantage, and help synchronize that way. So the final contradictions, and contradictions are maybe sort of a theme here, but is for culture. If culture is one of the ways that our systems are connected, then to synchronize on reliability, we actually need to have a culture that embraces failure. Most times when systems fail a lot, they're synchronized on cultures that either ignore failure, the companies that deploy first and test later, or they synchronize on cultures that are too afraid of failure, that it breeds distrust. Companies like the one that I worked at, where we weren't trusted to have elevated privileges, so we just hacked them, right? And that ended up reinforcing that idea that we couldn't be trusted. And, it just kind of kept things going in this state of distrust. So, what does embracing failure look like? If we wanted to, again, think about promoting this culture to synchronize on reliability, I think there's really three parts to this that every service team in every organization needs to synchronize on. And the first is to acknowledge failure. And acknowledging failure doesn't mean that we're saying failure is okay. One of the principles from the site reliability engineering book that Google originally published is that failure is a normal part of systems. And sometimes this makes people, especially managers and execs, really nervous because it sounds like we're saying that failure is acceptable. Failure being a normal part of systems means that incidents are going to happen, and we need to acknowledge that they're going to happen. But this helps us build a culture that is aware of failures without being afraid of failure. And this all leads to the next step, is that once you have a broad culture that acknowledges failure, you can start to measure it. There's an old saying that you can only improve what you can measure. And if you can't measure it, you can't improve it. So gathering all the data that you can in an objective way will help you understand failure. And oftentimes, most orgs do a post-mortem. And I think it's become common. An incident happens, you do some sort of review, and hopefully they avoid blame. And they come up with some action items and fixes that will help prevent a recurrence. But this isn't really enough to help synchronize teams on reliability, right? It keeps that knowledge constrained. Maybe you share that postmortem, you report it to other teams so that they might realize that they have a shared flaw or risk so they can implement the same fix. But I think ultimately you need to do a broader analysis, not just have postmortems and share that information, but start to take a look at your incidents as a whole. So I wanted to share a talk that Alexei Lacroix at Datadog, he's the CTO, gave at Monotrauma in 2018. When I worked at Datadog, we'd capture data for everything, right? Data was in our name. And so as a monitoring company, we were huge on data. Alexei, Datadog CTO, analyzed the reports. So he decided one day he was going to take a look at all that data, and he gathered up all of the reports, which at that point was over 1,000 different incidents, both minor ones, major ones. And he used that information to find trends. And from that, he could address larger engineering culture and processes. Rather than just individual teams becoming reliable by having postmortems, which again is fantastic, but doesn't build a larger culture, by analyzing everything, it was one of the ways that we realized we were all interconnected. And so it allowed us to synchronize on reliability. I'll post a link to that talk later in the resources. So I can't talk about chaos theory and reliability without mentioning chaos engineering, right? So the third way that I think we can embrace failure as part of that cultural change. Ultimately, embracing failure means turning it from something that happens accidentally to your systems into a tool that you can use to control and improve them. So I'm not going to dive too deeply into chaos engineering because we've got a bunch of better resources online. But here's a few, right? So I made bit.ly links for them. The first is a bit about what is chaos engineering. Simply put, it's another bit of science. It's science. You follow the scientific method to examine your systems. It's not just about randomly breaking things. But I'm hoping you want to get more into it. So the second link there is 4 experiments that you can start with. And then we do have more educational resources. So if you go to gremlin.com/certification, we actually have online learning resources and a certification program for you to dive a bit deeper. But I wanted to come back to the general topic and just reiterate that our systems are connected or interconnected in many ways. And we have to think about that because these connections influence how they behave. Right? This is the larger idea of chaos theory, is that there's a lot of influences on the things that we work on. But one of them from chaos theory is that we need to use these interconnections to synchronize, and we can synchronize on reliability. Right? So think about not just chaos engineering, which I'd love to have you explore, but think about the ways in which your systems are connected and how you can leverage those to become more reliable, even on systems that you don't control, right? Have influence on others in your organization. So as mentioned, posting some resources, that talk from Alexei, that's at that first link, Analyzing Failure. Highly recommend it. It's a really fantastic talk. And again, he did review over 1,000 incidents and what we learned from them. And so that's an interesting one to take a look at. Those links about chaos engineering, feel free to explore that or reach out to me on your own. And then again, questions. I'm happy to answer your questions. I think we're going to open up for some Q&A time now. So feel free to post that in chat, and Cody here will help moderate that. Otherwise, if you want to email me or get in touch later, there's my contact info.
So yes, Jason, I'm looking through the questions in the chat right now, and it looks like we've got a question right here, or it's more of a comment, but it says one problem, shouldn't ditch change management altogether unless seeking real chaos?
Yeah, I mean, I think that's a great comment, right? A lot of times change management gets a really bad rap because, a lot of engineers were looking at velocity. How can we make these changes quickly? How can we quickly iterate, which is a good thing. And oftentimes I think change management gets that bad rap because people see it as slowing down the process. And some of that, again, is, it can be used for bad, just like chaos, right? Like chaos theory, I mentioned some of the ways that we're connected. And it is this weird conundrum. Like they could be used for bad. You can influence for unreliability, which is what we normally see with cascading outages. But if you think intentionally about these, they can be used for reliability. And so as you think of change management in your organizations, some of that comes down to, yes, you've got that traditional track and it slows things down, but how can you take a look at your systems and what are some of the cultural ways that you can instill and spread a synchronization of reliability through that change management process? And that may be instilling a little bit more trust and lightening the system to get more people on board and get more people actually bought into using it. So some things to think about there. But yeah, absolutely. Change management should not just be pitched out altogether. I think it needs to be thought about in an objective way.
Awesome. I think that more than answered that question. So I really appreciate that. Our next question reads, for people new to chaos, where do we begin? Use tool, manual, etc.
Yeah. So this kind of dives into some of the resources here. So where to begin, that 4 experiments to start link is a fantastic one. But generally, the advice is to start small, right? So I think manual is an easy place to start. You do have to be careful and be safe. So don't start in production, start in your development environment. And then as you become more comfortable with that, whether it's manually or using a tool, you can move up to your staging environment before going into production. All that said, tools are fantastic. They make it easier. A lot of the tools out there, Gremlin included, we've thought about safety and we use it ourselves. So you don't have to worry about those edge cases because they've been taken into account, right? We have experts that have built the tools. And so you can kind of rely on that. So starting out, I say go for something small and go for what's easiest. If you want to give Gremlin a try, actually, I think if you hit almost any of those Gremlin links that I've got there under the chaos engineering section, there is a link on Gremlin to sign up for a free account. So Gremlin, we do have a free tier, lets you try everything, provides access to all of the attacks that we offer. So that's a great place to get started. And then, install that on a dev environment and test things out.
Perfect. Jason, that's all the questions I'm seeing right now. So I'm going to go ahead and give our attendees a few questions or a few minutes to send in a couple more. In the meantime, I'm going to go ahead and announce our Amazon gift card winners. So our 4 winners of our $25 Amazon gift card. First one is Karen L. Our second winner is Raphael V. Our third winner is Alan L. And our fourth is Auntie K. So congratulations to the 4 of you. Keep an eye on your inbox to claim that gift card. And if you don't see an email, just check your spam folder. So I am not seeing any more questions at this point in time. So I just want to go ahead and remind our audience that the session is recorded. Following this webinar, you'll receive an email to access the on-demand, or you can find it living on the devops.com website. Just visit devops.com/webinars and look at the on-demand section. Jason, again, thank you so much for being here with us today. This was an awesome topic. And I love the idea of chaos theory and kind of everything falling into place to just work. So I really appreciate you taking the time to be with us. Do you have any closing remarks before we close out and move on with the rest of our day?
No, I mean, I think I expressed it clearly in the talk, but yeah, hoping people will start to, spend some time, think about your interconnectedness and how you can leverage those for reliability, for good.
Perfect. So Jason, thank you. I'd like to thank our sponsor for today's webinar, Gremlin. And my final thanks goes to you, our audience, for being with us for today's presentation. Please fill out our post-webinar survey, and we hope to see you at a future TechStrong webinar. This is Cody J. Brown signing off. Have a great rest of your day, everyone.